All right, let's go ahead and work our way through it. Okay. So we're starting off with number 1. So AGB. How do I figure out AGB? Sorry. How do I figure out AGB? Yep.
63 plus 90 plus x equals 180.
Good. So I have 2 labeled angles in that triangle. I can find the third easily. So 63, 90 is 153. So 180 minus 153 is 27. Is that right? Did you guys get 27? Okay. Okay. How about EGD? EGD.
163 plus 90.
EGD. Oh, vertical angles, right? So if this one's 27, this one's 27. So it's got to be 27. Okay. And then I told you to skip to number 5 before we do anything else, okay? So this is when my scale factor comes into play. So I have 2 corresponding parts in this 3 right here and this 6 right here. So I'll just do small over big. 3 over 6 equals, if I'm trying to find this piece back here, I'm going to use this piece back here, which is 3. 3 over x. We can all see that x is going to be 6, but that's not the answer to my question, right? That tells me that this whole piece back here is 6. So what's this part of it? It'd have to be 3 because this piece is 3. Once you figure that out, what's the big glaring thing that you should be able to tell now? What kind of triangles are they? Well, yeah, they are similar triangles. We knew that from the get-go. They are isosceles triangles. That helps me out a lot, right? Knowing that these are isosceles triangles helps me out a lot. Because now I can go back to number 3, and I can say that I know BCG is 63. And if you needed a reason, I know we don't, but if you needed a reason, that would be the base angles congruence theorem, right? AG, I can use Pythagorean theorem for. I know one leg is 3, one leg is 6. What's the hypotenuse there? For AG, please. What is it? 6.7. We all in agreement? Okay. And then FE. So on FE, since they are isosceles triangles, that's going to be half of the 3, so 1.5. Okay, and then ED is also going to have to be 1.5. So GF, I do Pythagorean theorem again. What's that end up being? 3.4. Okay, and then AGC would have to be congruent to, similar to FGD. Since they are isosceles triangles, you could say DGF, and that would be good as well. Okay? All right, so there are a couple different ways that we can prove isosceles triangles. Not isosceles triangles. A couple different ways we can prove similar triangles, and the 3 ways are listed right here. Okay? And we have to be paying attention because with similar triangles, what is true of the angles in similar triangles? They're all the same, congruent, right? So in similar triangles, the angles have to be congruent. What about the sides? What are the sides of similar triangles? Remember what word we use for it? It's not congruent, right? We can't say similar. How are they similar? The same scale factor, we call that proportional, right? So they have the same scale factor, aka they're proportional. So angles have to be congruent, sides have to be proportional, okay? So when we are talking about the angle-angle similarity theorem, that means 2 sets of angles have to be congruent, right? So the angle-angle theorem would say 2 sets of angles have to be congruent. Because of the third angles theorem, we know that the third set are congruent as well. That's why we can prove that those are similar. Okay, so we can prove 2 triangles are similar by angle-angle similarity theorem. We can prove them by side, side, side. So side, side, side means those 3 sides are Proportional, right? So if we can prove that all three sides are proportional, we can say that they are similar triangles. Or we can do side, angle, side. Okay, so we would have to say two sets of adjacent sides are similar, proportional, with the angle in between them being congruent. You guys got that? So if we can say two adjacent sides, you can't have non-adjacent sides in triangles. If you have two sets of sides in a triangle that are proportional and the angle between them is congruent, then you can do side, angle, side. Okay, so those are the three ways that you can prove they're similar. So this is when it starts to get challenging, because you have to keep separate in your brain how we prove congruent triangles. Remember, that's everything, every possibility you can think of, except for AAA and donkeys, right? Angle, side, side. For similarity, you just have these three options: angle, angle, side, 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 angle, side. Okay, any questions so far? Okay, try 1, 2, and 3 together with your groups. So you have to decide if they're similar. If so, name the theorem and then write a similarity statement. Okay?
I said that one. They were similar.
Okay, what do you guys think about number 1? Can you say they are similar or not? Give me a thumb. Yes or no? You guys all say yes. What reason did you give? Side, angle, side. Okay, so that would mean the two sides that are labeled would have to be proportional. So let's make sure they are. So I'll do new over old. So 9 over 6 should equal 12 over 8. What do both of those reduce to? If I divide by 3 on top and bottom on the first one, divide by 4 on top of divide by oh my gosh, I can't speak. Divide by 4 on top and bottom on the second one. They both end up being what, 3 over 2? Okay, so that's a check. We got angle A is congruent to angle D. So we can say yes. We would say triangle ABC is similar to triangle DFE by side, angle, side. That would be my answer, right? All right, let's look at 2. How about 2? Give me a thumb on 2. Most of you are saying thumbs down. I see a couple up. Why do we say no? You might be tricked into thinking side, side, side right here, right? Why is it not true? Yeah. So the similarity, they would have to be proportional, and they're not proportional, right? So if I do like the bottoms, that would be 3 over 4 is not equal to what, 4 over 6? Because 4 over 6 reduces to 2/3, not 3/4. So I would have to say no on this one. Okay, and then number 3. What do you guys think? Give me a thumb. Yes or no? Ooh, we're kind of torn on this one. Should I tell you the answer? It's yes. Okay, so we said side, angle, side. Where's the angle come from? Yeah, vertical angles. So I'm guessing those of you that missed that one probably said because of the angles. Okay, but remember, vertical angles are congruent. Okay, so we have to check and make sure proportional. So 6 over 12 equals 4 over 8 equals 1/2. And then we can say angle ABE is congruent to angle CBD by vertical angle congruence. And then we can say yes, triangle ABE is similar, not congruent, similar, right, to got my triangle CBD by side angle side. Okay. Good job. Prep time.